Okay.
Okay, so we are recording.
Okay, so welcome everybody to this special event, this VMware SDDC Roadshow with a very special guest today. Here I'd like to introduce you to Mr. Frank Denneman. Good morning, Frank.
Good morning.
And then Duncan Epping. Good morning, Duncan.
Good morning.
And last but not least, Cormac Hogan. Good morning.
Buongiorno.
Fantastic. So I'll just quickly switch to Italian for a second, so I'll introduce the event and then I'll hand it over to you. Buongiorno a tutti, siamo giunti al secondo appuntamento di un ciclo chiamato Primavera col VMUGIT. Io sono Danilo Chiavari, insieme a me c'è Lino Telera. Buongiorno Lino.
Buongiorno, vedete?
Ti vediamo e ti sentiamo forte e chiaro. Buongiorno. Grazie. Anche ad Antonio Amoroso.
Ciao ragazzi, buongiorno a tutti.
Buongiorno a tutti. Allora, questo evento di oggi è incentrato su un roadshow con 3 sessioni molto interessanti di approfondimento su vari argomenti, presentati dai 3 speaker che abbiamo introdotto poc'anzi, che insomma, non hanno bisogno di presentazione. Qualche parola velocemente su di noi. Siamo un gruppo di utenti VMware, la community locale del VMware User Group. Ci trovate sul nostro sito vmug.it. Siamo anche presenti su YouTube con un canale dove condividiamo tutte le nostre sessioni e registrazioni. Abbiamo ovviamente anche un canale Twitter molto, molto attivo con cui potete interagire direttamente con noi, e un gruppo LinkedIn su cui spesso postiamo le nostre attività e le sessioni come quella di oggi. Quello che abbiamo ideato è un ciclo di 3 eventi chiamato Primavera con il VMUGIT, un evento al mese per 3 mesi. Siamo giunti al secondo appuntamento oggi, 14 aprile, e abbiamo ancora davanti un altro evento a maggio. Chiaramente dal nostro sito potete iscrivervi a tutti e 3 gli eventi e vedere il calendario dei prossimi appuntamenti. Gli eventi che abbiamo pensato per questa primavera sono di vario tipo. Si parte da un approfondimento direttamente su Tanzu, su Kubernetes, poi oggi c'è questo workshop con tutte le novità di vSphere, vSAN per il mondo anche di Modern Application, e per ultimo a maggio abbiamo un evento direttamente con l'esperienza, la testimonianza di un evento di un utente finale che ci racconta il percorso di trasformazione che ha avuto verso l'hybrid cloud. Passiamo rapidamente all'agenda di oggi. Abbiamo un'agenda molto fitta, un paio d'ore insieme, divise in 3 blocchi separati, con uno spazio per domande e risposte da 10 minuti dopo ogni sessione. Ovviamente vi invitiamo a utilizzare anche la chat, il pannello domande e risposte, per interagire direttamente in tempo reale con noi. Detto questo, Antonio, Lino, aggiungiamo altro o passiamo direttamente la parola ai nostri speaker?
No, io direi di non farli attendere i nostri ospiti e di passare subito la parola ai nostri speaker. E niente, usate, come aveva già detto Danilo, la chat per le domande, e così noi diciamo saremo in back-end, faremo un po' da moderatori e basta, nient'altro. Buon divertimento.
Let's switch back to English. Thank you everyone, and the word goes to Frank.
Thank you. So let me share my screen. So hi everyone, my name is Frank Denneman. I'm a chief technologist working at the office of the CTO within VMware, together with Duncan and Cormac. Now I have the pleasure to open up this roadshow, and I'll start presenting my session first. After that, Cormac will do his part, and then Duncan will end this roadshow, will finalize this roadshow. So during the 3 presentations, please use the chat function to ask questions. We'll try to incorporate your question during the presentation, but sometimes we cannot fit it in inside the session itself, and so either the other speakers will answer your question, or we will wait and do it after a short Q&A session after each presentation. So don't hesitate to ask any question. So the agenda for this session is the introduction of containerized workloads in your data center. How do you create a platform that allows multiple persons to deploy workloads, containerized workloads and virtual machines on vSphere, and how can you create this consumption strategy? So throughout this session, I'll talk high over about Kubernetes and Tanzu, and then Cormac will dive into that particular those particular topics in more detail. So let's start off with the introduction of containerized workloads. So what we see when we talk to our customers as VMware is that there's a lot of customers who are slowly replacing the commercial off-the-shelf software with containerized or self-built applications. Now, a commercial off-the-shelf software, something that you can basically install with a file or with a DVD or something like that. So think about Exchange, for example. So what we see is that there's a lot of newer types of workloads being produced by the organization itself, and one of the analyst companies, IDC, did some research, and they are prognosing that over 500 million of these cloud-native applications are expected to appear in the enterprise data center over the next 5 years. Now, that seems to be an absurd number. 500 million apps is a lot of applications. But if you look at the new developer paradigms and the new types of applications, take, for example, a CI/CD pipeline or even machine learning workloads, that number is not really weird anymore. So for machine learning, you typically use data, you create a model, and together you will provide predictions or a recommendation system for an application. Now, in order to get the data on the compute platform and in order to get the data in the right shape for that ML model, you need to create all these types of pipelines. And within a pipeline, there are multiple steps, and each of those steps are typically a microservice which runs in a container. So what you see is that a typical machine learning workloads will spin up more than 20 or 30 containers just to get that model up and running. So that 500 million doesn't really sound that weird anymore. Now, what you can say is that, hey, I don't have any developers in my organization and I'm not dealing with machine learning. So is this talk for me? Now, what we see is that there's a lot of software vendors that are looking at containers as a distribution model for their software. So think, for example, about SAP, the modern type of applicational functionality for their software is actually being distributed in a containerized format. So even if you don't have developers, and even if you're not going to build your applications yourself, there's a big chance that you will get new software in your data center based on a containerized format. Now, that means that we have to think, we as VMware have to think about that modern application architecture. So let's go over what that actually looks like. And so what you start off with a containerized application. So let's use an online bank app as an example. Now, modern banking functionalities are typically generated or created in this new cloud native application, and one of the things is it will land in a container. Now, even if you have that containerized application, you're not done, because typically with these cloud native applications, it's in a distributed manner. So there are more than one containers. It's not like a VM where you basically run your Exchange in. There are multiple containers. So you need to have an orchestration layer that can make sure that the application runs perfectly, has the right performance, provides availability, and all those things. Now, the most dominant container orchestration in our industry is Kubernetes. Now, if you zoom into Kubernetes a little bit, we can distinct between two different types of nodes. We have the Kubernetes control plane nodes, and we have the worker nodes. The worker nodes are the actual systems that run the containerized applications. The Kubernetes control plane makes sure that the applications are powered on, they stay powered on, and if they fail, there's some operator or some scheduler that will make sure that everything is returned to a what's called a desired state. Now, that by itself is typically the story that you will see in modern media when they're talking about applications. Everything is about containerized applications and everything will run on Kubernetes. And that's the end of the story. But that's not the end of the story in modern enterprise data centers, because if you just created an online bank app, for example, and you put that in a containerized environment, customers need to log on. So how do you verify that those are actually your customers? And once they log on, how can they actually access their bank account? So you need to connect that containerized application with these services. And these services typically run in virtual machine environments. Think about your customer database that runs in a database, typically in a virtual machine. So what happens is that you need to provide a platform that allows the containerized application to communicate with those traditional applications running in other constructs like virtual machines. And so if you look at the responsibility and the questions of the personas, we have now the developer focusing on the online bank app and the IT ops teams looking at the overall picture. So the developer will get questions like, okay, so how do I deploy the app? How can I operate it on day two? That if something happens to these traditional applications, I still have a functioning service. What type of tools can I use? I need to look at my containerized application, but I also need to verify the things that are happening in the data center that are beyond my Kubernetes environment. Now, for the IT ops teams, they have to ensure the availability of the entire app. So the online bank app now and the traditional applications. So they need to figure out, how can I communicate with Kubernetes? How can I understand Kubernetes from a status perspective and all those things? And how do I ensure security? It's a different control plane. That means we have different role-based access. We have different types of elements that you need to consider. Quality of service, same thing. It needs to perform, right? So how do you provide that the Kubernetes environment provides the same performance as your virtual machine environment? The tools used and the criteria used should be understood by the IT ops team. And of course, how do you control the cost of the infrastructure? So we thought about this and we looked at the questions of the customers. And so we started to focus on Kubernetes actually quite early. Kubernetes was released in 2015. And so in 2017, we already released Project Hatchway, which provided persistent storage volumes for containerized workloads. In 2018, we provided NS6, or we released NS6T that provided containerized network services such as load balancing and policies. In 2018, we also acquired Heptio, which was founded by the two founders or the two inventors of Kubernetes while they were still at Google. And another thing that Heptio had was this upstream compliant Kubernetes distribution, which we could use in our strategy. Now, in 2019, we announced vSphere with Kubernetes at VMworld 2019. Nowadays, it's called vSphere with Tanzu, and Cormac will go into the details of all the names and all the different types of offerings on that suite. So if we look at what we can offer today, we have two distinct elements. We have vSphere 7 with Tanzu, and that allows the customer to run Tanzu Kubernetes Grid services, which is a Tanzu, or sorry, a Kubernetes distribution running inside virtual machines. But we also allow vSphere pods, and vSphere pods is our way to provide a way to run containers natively inside the kernel. So let's look at that a little bit more closer. So by itself, a container is just a collection of processes. So you need to have an operating system to run those processes, that container. And typically what we see is that the majority of containers run run on a Linux operating system. Yes, there are possibilities of running a container in a Microsoft environment, but the overwhelming majority of containers run in a Linux system. Now, contrary to some popular belief, ESX is not a Linux operating system. So we cannot deploy containers directly on ESX. Now, one of the problems you face with just a container is because it's a process, it's capable of seeing the entire system and all the other processes. Now, that's something that you do not want, that a container can view and access all the other processes running on the ESX environment. So we need to create some containment system. Now, what better way than to use a virtual machine, which is a containment environment? Now, one of the things that we've done is we actually got it to become very lightweight. So we have this lightweight virtual machine running Photon OS as the Linux kernel, which has a tiny footprint. And we used para-virtualized devices to even contain the drivers as well. And so this pod VM, this vSphere pod, is now really tiny and is focused on delivering the containerized workload. Now we inject a container runtime and we inject a system where we can interact with this vSphere pod, but that allows the customer to run that container in a native format. So if you go into vCenter and you run a vSphere pod, you will see that vSphere pod popping up in the UI, and you are allowed to do a lot of things similar to working with a virtual machine. Now, the majority of the Roadshow is actually focused on TKGS. That is the upstream compliant distribution of Kubernetes running inside virtual machines. And vSphere 7 with Tanzu has this service that allows you to easily spin up your Kubernetes cluster on that vSphere platform. And it allows us to start providing a self-service platform for developers because of this, because we allow the developer to use their own tools to interact with the vSphere platform. But the great thing is that we still use vSphere. So we still have our own our tools that we've been using for the last decade, and it allows the infrastructure team to manage the entire system, though they manage the virtualized platform, but also the Kubernetes environment and all the workloads that running in that environment. So the next step is, how do you create this self-service platform? And so one thing that you need to do in order to run TKGS and to run vSphere with Tanzu is to enable workload management. If you go into the vCenter UI and you look for Tanzu, there is no functionality that is called Tanzu. Within vCenter, it is called workload management. Now, Cormac will go into the details on what to do in order to install it during his session. But one of the things that Cormac also done is he created this fabulous write-up on his blog that will take you from step to step to install workload management on your environment as well. So if you want to install it at a later stage, go check out his website. Now, if you've gone through all those steps, what you will see at the end is the right side of my screen is where you have your cluster environment, and now there's this resource pool called namespaces. And within that resource pool, there are 3 virtual machines called supervisor, control plane, virtual machine. Now, supervisor is our designation, our name for a vSphere cluster with Kubernetes enabled. And so this supervisor cluster becomes the platform for others and for the IT ops teams to deploy Kubernetes environments and virtual machines. Now we are creating 3 control plane VMs because we want to provide a highly available control plane, and I'll talk about that a little bit later. Now, that means that from this point on, we have a Kubernetes orchestration layer running inside the vSphere platform, and we expose all these services such as a Kubernetes API endpoint. So from this point on, the developer can interact with the vSphere platform using their own native tools, for example, the Kubernetes APIs or command line interface, to actually interact with the vSphere platform, and in order to basically deploy their own Kubernetes environment. So think about this Kubernetes API endpoint the same way as a developer goes to Amazon, go to the web page of Amazon in order to deploy a Kubernetes environment on Amazon or Azure or whatever cloud platform that you use. But with this, the developer can use their own command line interface and go directly into the data center and deploy their Kubernetes environments on in the enterprise data center. Now, that might freak out some of the administrators on this call because they are now basically saying, hey, I just handed over the keys of this vSphere cluster to the developer, and this developer can start to deploy all these virtual machines, all these Kubernetes clusters that can become noisy neighbors. So I want to control this a little bit. I want to guide the developer. And because of that notion, we've introduced a construct called a namespace. And this namespace is a boundary of resources and quality of services for the developer to consume, and it's controlled by the ops team. So how do you introduce that? Now, if you enabled workload management, there's this new option called create namespace. If you click on that, you will see the screen on the right side of the presentation. There you select the cluster, you give it a name, in this case, giving it online bank app as a name. You select the network, which is created during the workload management configuration phase, and then provide a description and click on create. Now, from that moment on, in your host and cluster view, you will see a new icon with that's the namespace icon with the namespace. And here you will see the online bank app appearing beneath the namespaces resource pool folder. And if you click on that, you will get to see this summary page. And the summary page is really great because in one view, in one easy view, you see all the quality of service defined for this environment. So now think about using these namespaces as a way to manage your applications, the collection of elements that actually create this application. So think about your virtual machines and your TKG clusters. They can all be a part of this namespace, and you provide particular storage resource and particular compute resources. Now, at this point in time, you cannot provide access to somebody else because you need to define the permission and the storage policy. So the next step is to add the permission. So maybe you created this group for developers and you define that here, and you provide their role can view or can edit. And then the next step is create a particular storage policy. That is the storage policy that is used for the machines that will be deployed in that namespace. Now, the next step is optional, and that is actually to define a resource limit. And a resource limit is physical resources limitation, meaning that in this case, I define 50 gigahertz of CPU resources and 64 gigs of memory resources. And so the developer can deploy workloads, but in reality, they can only consume up to 64 gigs of memory and 50 gigs of CPU resources. Once I click on OK, I actually see that limit in the summary page. So in one easy view, I can now see the status, I can see the capacity and the usage and the limitations of the compute resources, who can access that environment, and what the storage policies are. I haven't deployed anything because the developer, this is one for the developer. So at this point in time, I can hand over that environment, that API context, and say to the developer, go ahead and use your own tools to deploy your environment. So they will use like a command line interface or maybe a CI/CD pipeline, and they will interact with the Kubernetes API endpoint to deploy their Kubernetes cluster. And the moment it's deployed, they can use that Kubernetes API point to deploy their environment. So that vSphere platform now becomes this self-service platform for developers, while the IT ops teams can manage and control the consumption of this platform while still deploying virtual machines, of course. So the next step is consumption strategy. Although you set a limitation, or you might set a limitation on the namespace, it actually makes sense to have a conversation with the developers to explain the nature of the vSphere platform and what type of services the developer can use to actually improve their own Kubernetes experience. And so one of the things that you have to realize is that they're using their own manifest to deploy their own TKG cluster. So you're not a part of that the deployment process anymore. They're not calling you to ask, hey, can you give me a Kubernetes cluster with these type of control planes and these type of workloads? They can do the same because they interact with that Kubernetes API point exposed by the supervised control plane. So there needs to be some guidance. Now, one of the things that we've done is that we've created these virtual machine classes that are available to the developers, and the developer need to specify these virtual machine classes in that manifest, in that YAML file. And so I zoomed in to a particular area of a YAML file. Typically, YAML file has a lot of settings, and I just focused on the virtual machine class. And here you will see that the topology of this Kubernetes cluster, this TKG cluster, has a single control plane, and the class of that control plane node is a guaranteed median. Now, for the worker nodes, the developer chose 2 worker nodes and with a virtual machine class of guaranteed large. Now, in total, there are 16 virtual machine classes. So what does that mean? So what type of impact can it have on your platform? So there are 2 types of classes. There's this best effort class and this guaranteed class. Now, with the best effort class, the name says it all, we'll try to provide you the resources that you demand, but the moment there's contention, we will provide you with the resources based on the availability and based on the entitlement that those virtual machines have. So basically shares an activity. So there's no reservation on CPU. There's no reservation on memory set for those virtual machines. Now, this is basically a very good class for interactive test environment and like test and dev, not type of production, because for production you want to have consistent performance, and consistent performance is reached by providing physical resources that are available to that environment all of the time. That's where you want to use a guaranteed class, because it uses a CPU reservation and a memory reservation that's equal to the configuration of the virtual machine class itself. So there are 8 classes, sizes. And so let's use the large, for example. So you have a guaranteed large. That means that the virtual machine is deployed with 4 vCPUs, 16 gigs of memory. And so there's also 4 vCPU of CPU reservation and 16 gigs of memory reservation. So that has some impact on your vSphere environment. Think about HA, think about admission control, think about DRS. And so one of the things that you have to educate your developers, and so instead of doing interacting with the developer during the provision process, maybe you can think about having tech talks and having like advisory councils to the developer saying that, look, this is the way you want to deploy things on the vSphere platform. They did the same thing for Amazon and for Azure. They looked in, okay, how can I deploy things on Amazon and how can I deploy things on Azure? They have to have the same mindset. How can I deploy things on my local vSphere environment? So one of the things that you can talk to your developers about is like, how does the cluster footprint look like? So when we look at control plane nodes, how many operations do you expect? Are you going to build up and tear down containers quite fast? So is there this churn of containers popping up and dying down? If that's the case, if there's a high activity going on, you might want to provide more resources, right? Because there are more operations. But if it's just a slow acting Kubernetes cluster that sees a container pop up and they do some testing, and then after a few days they tear it down and they deploy a new one, doesn't have to be that big, right? So from a production and interactive test perspective, that's where you want to differentiate between virtual machine classes. Production, guaranteed. Interactive test environment, maybe a best effort class will be sufficient. Like I said, guarantees are reservation impact DRS and HA. So think about the size of your control plane nodes and, of course, the amount of control plane nodes, because the Kubernetes control plane node has a high availability systems inside. But here's the thing: you're running it on vSphere, on the vSphere platform, which also have vSphere HA. So there are 2 captains on this ship that try to manage availability. And the interesting thing is vSphere HA might be actually quicker to respond to failure than Kubernetes. So if we dive into the whole Kubernetes platform a little bit deeper, that here you see that in order to run pods, you need to have a worker node. But in order to schedule the pod on the worker node, you need to interact with the control plane. So either you, the developer, or a CI/CD pipeline interact with the Kubernetes control plane by using the API server. Now, on each control plane node, there is this API server, and everything that you you interact with the API server, like you're deploying a manifest or you're changing something. Those changes are stored inside the etcd database. It's a key value store, and that's the most important part of your environment, because once it's stored in the etcd database, there are these events, triggers, the actions of the schedulers and the operators and basically the controllers inside the control plane of Kubernetes in order to do the things that are required in order to start or restart a pod. And so the state of the etcd environment is really important. And because it's a quorum-based systems, that's the reason why you always see an odd number of nodes being deployed for Kubernetes. You either see 3 nodes, maybe you see 5 nodes, or in some cases you see 7 nodes. The reason why you have these numbers is to tolerate the control plane node failures. So if you deploy 3 control plane nodes, you tolerate 1 failure because you need to have the majority of nodes up and running. So in order to tolerate 2 control plane nodes, you need to deploy 5 control plane nodes, 7 to tolerate 3 failures. Now, that's a big footprint for an environment that just want to run these efficient containers. So try to think about HA and how it can mix and match the high availability environment for Kubernetes. So if we dive a little bit deeper in the way Kubernetes handles control plane nodes, here is this timeline. And I will share the presentation with leaders so you can watch this timeline more easy or for the time you want to. But the idea is that in a worst case scenario, when a node failure happens on the in Kubernetes, it can take up to 350 seconds, or it's a little bit more even, before Kubernetes will start to initiate some actions to recover from that failure. Now, in reality, what you typically see with HA is it takes up to 30 seconds to understand what's going on, and then basically we will initiate the restart process of virtual machines. So typically, you will see that HA will restart a Kubernetes node way before the Kubernetes will actually determine that a node has failed and will start to do its initiation. So there's this mix where you can basically provide a high available environment while still having a smaller control plane footprint that is necessary when you want to deploy Kubernetes on bare metal, for example. And so from a worker node perspective, same thing applies. Now, how many operations does the container do, and how many resources does the containerized application require? And that defines the size of the worker node. Same applies, guaranteed best effort. If you're running production, use guaranteed, of course. And now the availability of the containerized workload depends the number of worker nodes. So if you have a containerized application with 3 replicas, the best thing to do is to offer 3 worker nodes. Now, a worker node is perceived as a soft fault domain. What I mean by that is Kubernetes will deploy a container or a replica on a worker node in an isolated manner, meaning that if you have 3 worker nodes and you have a replica count of 3, every replica will end up on a different worker node. But if you have 6 replicas and you still have 3 worker nodes, 2 replicas will end up on the same worker node. So this is the best effort way of distributing those containers in the best possible way, but it doesn't fail. Basically, if you go beyond a particular number of worker nodes with your replica count, it doesn't fail the development. It just does in a best effort way. So test and production guaranteed for production, typically production, and best effort for testing environment. Now, the last thing that I want to show you about this is that we are deploying, or Tanzu or workload management are deploying the namespaces and the environment underneath a namespaces resource pool folder. So if you are using that same environment for virtual machines, you have to think about what's called the sibling rivalry, because virtual machines typically end up in the highest level of the cluster tree, basically right below the cluster environment, and that's next to the namespaces resource pool. That means that it's going to compete with its resources, with its shares and its activity to the parent folder, the namespaces folder, for all the resources below it. So if you have a lot of test environments that are using best effort classes, they are basically being they're basically getting the resources from that namespaces based on the shares value of that namespaces folder or resource pool. And so there can be a situation where a particular virtual machine has more entitlement than the entire Kubernetes stack inside that namespaces structure. So if you have those types of deployments, maybe you can think about having resource pools for your virtual machine deployments as well. One thing that we've introduced in vSphere 7 is the scalable shares environment or the functionality, and that allows us to dynamically change the share value of the resource pool folders that represent the underneath or the underlying virtual machine structure. So please check that out. Now, it's quite a complex story from at the back end, or basically a deep dive. And so instead of spending a half hour doing this this roadshow, I created this deep dive article that you can read on your own leisure. So please check that out on my blog site, frankdenneman.nl. So overall, the questions you have to ask yourself and the customer, the developer is, what type of Kubernetes landscape do you expect? Are you going all in with Kubernetes or Kubernetes on vSphere? Are you expecting a lot of developers hitting that environment? And if that's the case, maybe you want to think about separating your Kubernetes environment from your virtual machine environment that you use for your traditional applications, same as what you do with VDI and your server virtual machines as well, because there's still a maximum number of vCenter operations available. And if you have like 1,000 developers hitting your vCenter, you might end up not being able to manage your entire environment anymore, because you are basically back in the line of doing things in your vCenter environment. So another thing is what's what's the expected lifetime of Kubernetes clusters? So if you see a lot of clusters being spun up and being destroyed, think about that from an operation perspective as well, and the impact of that on, for example, DRS, the number of operations being introduced by workload disappearing and reappearing again. One of the first steps that I recommend you to do is go take a look at the high availability combination of vSphere and Kubernetes and understand the relationship and the reactions and the responses of the different control planes. And with that, I am at the end of my presentation. Up next is Cormac, and Duncan will close off this roadshow. Guys, are there any questions? I haven't seen any pop up in the QA.
There was one in the Q&A, Frank, about the number of supervisor VMs to ESXi hosts. I think we have the answer that there's a maximum of 3 supervisor VMs. Doesn't matter really the size of the cluster. But you will need a minimum of 3 ESXi hosts in the cluster, right?
Yes, that's correct.
And they also have to have shared storage, right?
That's the supported configuration. Yes.
Right. Great.
In home labs, that's a different discussion. But let's talk about production environments and support, and that's the minimum supported configuration.
Perfect. That was the only one that came up. Yeah.
Thanks for answering.
Sure.
I think I run a little bit over time, so.
Yeah, we're just into the Q&A section, so we still have a couple of minutes. If anyone would like to type something in the chat or the Q&A, or even whatever way you want to reach out to us. Yeah. Share anyway while we're waiting. Okay, I think we may as well get going if that's okay with everyone. We can have a few minutes at the end for additional Q&A if necessary. Okay, so hi everyone. My name is Cormac Hogan. I work with Frank and Duncan in the Cloud Platform Business Unit, or the vSphere Business Unit, if you like. And so I'm going to be following on from Frank's initial presentation. But I'm going to be looking at this from a more practical perspective, where we go through the deployment of vSphere with Kubernetes, or vSphere with Tanzu, as it is now known. And so what you'll find is that we have renamed these products a number of times, and it has sort of got a little bit confusing. So I'm going to spend a little bit of time at the beginning just explaining what we're going to be talking about and how it fits into the whole Tanzu portfolio. And then we'll get into the deployment. So we'll set up a load balancer service. We'll set up vSphere with Tanzu. We'll build a TKG guest cluster, Kubernetes cluster inside in one of the namespaces as well. So I have a few demonstrations to show you. Yeah.
I'm sorry, sure. Your volume is a little bit low.
Maybe my microphone is a little bit away from my mouth. Is that better?
Yes, thank you very much.
Okay, great. I'll try to talk up. It's my lovely, soft Irish voice, you see. That's the problem. So I'm going to spend a little bit of time just going through the different Tanzus. And what we're talking about today is vSphere with Tanzu. And I will spend a little bit of time because you may have heard the term VCF with Tanzu as well. So I'll try to explain the difference between those additions. But then we'll get into deployments, and I'm going to show you how you can deploy the HA proxy appliance. This provides a load balancer service, which is critical for any sort of Kubernetes. We'll then go ahead and we'll set up the workload management. Now, Frank has talked a lot about this already, but workload management is basically the UI term for vSphere with Tanzu. So you won't see Tanzu in the UI. What you'll see is this thing called workload management. And so once we have that supervisor cluster with workload management all set up, we will deploy a guest cluster, which is basically the primary use case of this, the idea of being able to deploy multiple Kubernetes clusters and giving them to individual developers or teams of developers on the same vSphere platform. I'm going to finish then, and it's kind of nicely segues into Duncan's section where he's going to be talking about vSAN in earnest, but I'm going to talk to you about a feature that we've just announced with the release of VCF 4.2, which is the vSAN data persistence platform. And basically this platform allows you to have, how would you say, application services, I guess, made available on a per namespace basis. So I'll talk a little bit about that as I finish. Okay, so which Tanzu will we be talking about? So we have Tanzu all over the place at the moment, as you're probably well aware as VMware customers. Let's talk about TKGI, or the Tanzu Kubernetes Grid Integrated, or just Tanzu Integrated for it. This is the old enterprise PKS product, the Pivotal Container Service. It was formerly known as well. And this was a joint initiative between VMware and Pivotal at the time to release a brand of Kubernetes that could run on vSphere. So that is now called Tanzu Kubernetes Grid Integrated, or TKGI. I'm not going to be talking about that version of Tanzu. There is another version of Tanzu. It is Tanzu Multi-Cloud, also shortened to TKGM. And this is Tanzu Kubernetes Grid Guest Clusters, which can be deployed on multiple clouds. So it could be deployed on vSphere on-prem, but it could also be deployed on AWS or Azure or Google Cloud or whatever. How this works is it sets up a small, lightweight management cluster. And then from that management cluster, you can deploy out Kubernetes guest clusters. So that Tanzu Kubernetes Grid Multi-Cloud, or TKGM, I'm not going to be talking about that either. The Tanzu that I am going to be talking about is what we call Tanzu Kubernetes Grid Service. This is a service inside in vSphere with Tanzu, which works in similar way to how the management cluster works in TKGM, insofar as you have the supervisor cluster, and from that supervisor cluster within vSphere with Tanzu, we can deploy out these guest clusters through the TKGS service. So that is what I will be talking about in this session. And I know it's only 10 minutes ago that Frank explained all of this to you, but I think just to recap what vSphere with Tanzu is we have our vSphere environment. Like I said, a minimum of 3 ESXi hosts will be needed, 4 really if you have vSAN, and of course shared storage between all of those. We can then go ahead and deploy the supervisor cluster. This is workload management, or vSphere with Tanzu, which is 3 supervisor control plane VMs. They all communicate to each other. They basically set up a Kubernetes control plane. Once you have that control plane up and running, you can then start divvying up the resources in vSphere environment into different namespaces. And Frank talked in detail about how you can set resources and limits and so on these different namespaces. And just to show you that you can configure and tune and set up privileges on a per namespace basis, so you can have multiple developer teams or individual developers isolated and not stepping on the toes of other developers or other development teams. So once you hand it off to the developer and you have the namespace configured, what are the kind of things that they can build in here? Well, one example, if you're familiar with the product vSphere Integrated Containers, or VIC for short, is the ability to deploy container images as VMs. So this very much is, there are, for all intents and purposes, they are containers, but they're wrapped in a virtual machine format. And so the great thing about this is it gives you the kind of agility of just working with containers, but you get the security and the isolation of a virtual machine. And these are what we call pod VMs. And these are available as an object that you can create inside in the namespace. But to be honest, the major use case is the namespace to deploy an upstream Kubernetes cluster, a TKG cluster. And this is where the TKG service comes in that you can create these Tanzu Kubernetes grid guest clusters within a namespace as well. And so you have some sort of nesting here. I suppose you have your supervisor control plane at the outer layer, with the ability to build upstream VMware engineered Kubernetes clusters within that cluster, or within that namespace in the cluster. And the thing is, it's not limited to just a single cluster. You could have multiple TKG clusters deployed in a single namespace as well. So hopefully that gives you a good recap on Frank's presentation. So I'm going to get it started now and talk about some of the different versions of vSphere with Tanzu it is, and try to explain what this VCF with Tanzu is as well. I think you all probably know what VCF, the VMware Cloud Foundation product is. It's basically our easy button for standing up a software-defined data center and then doing ongoing lifecycle management throughout the life of that SDDC. And of course, we bring in the compute, networking, storage, and through vRealize, we can embed vRealize in there as well for the management and monitoring and forecasting and all of that good stuff. So when it came to vSphere with Tanzu, there were a number of services that we added. These services, we can break them down as follows. I mean, there's a storage service, which basically allows Kubernetes to consume vSphere storage. Okay, so VMFS, NFS, vSAN, vVols, all of that good stuff. Networking service is important in Kubernetes because we have to secure pod-to-pod communication through overlays or tunnels. So that's one requirement of the networking service. And the other one then is to provide a load balancer service. So a front end for all your clusters and even your applications, which requires a load balancing service. This was provided by NSXT in VCF. The pod VM service, we just talked about that. It's basically containers in a VM. Again, just agility of working with containers, but security and isolation of a virtual machine. And last but not least, we had a registry service, which basically was built on top of pod VMs, but allowed you to store container images locally on premises rather than your developers going out to some untrusted registry and pulling down untrusted images. So this was using the Harbor VMware. It's another VMware open source product called Project Harbor, and that is our on-prem image registry service. So we had all of those services, but as I said, the main use case was basically building TKG clusters to be able to deploy out within a namespace your own upstream VMware engineered Kubernetes distribution. And that was the main service. So all of that was made available to the developers. They could just use it like a Kubernetes cluster, deploy out guest clusters. So all of that good stuff was provided by the initial release in VCF 4.0. And that still continues to be available today. We absolutely support customers, running vSphere with Tanzu on VCF 4.1 and 4.2, the most recent one as well. But not all customers have VCF. So we needed to come up with a solution for non-VCF customers. And this is what launched in 7.0 Update 1 and 7.0 Update 2. Essentially, what we did is we said we can now use vSphere networking. You don't need NSXT. You can use vSphere distributed switches. But that doesn't provide a load balancer service. So you had to provide or get a load balancer service from somewhere else. And so in 7.0 update 1, we released the HA proxy appliance to achieve that. And in 7.0 update 2, we have the NSX advanced load balancer, which is an Avi Networks. When we acquired Avi Networks last year, it's a product that they had in their portfolio, and it's just been renamed NSX Advanced Load Balancer. So those load balancer services are there, so you no longer need NSXT, you no longer need VCF in order to run vSphere with Tanzu, but you do have to stand up an individual load balancer service, whether that is the HA proxy or whether it's the NSX Advanced Load Balancer. Now, what you'll notice is the infrastructure services has reduced here. We no longer have the pod VM service, nor do we have the image registry available in the bring your own load balancer approach. This is because we don't have anything that provides pod-to-pod communication. So we don't have anything that provides the tunneling or the overlay networking that that allows you to do the pod-to-pod communication. So because we don't have the pod-to-pod communication mechanism, tunneling mechanism, we can't do pod VMs. And because the image registry is built on top of pod VMs, we don't have the image registry either. But we continue to have the TKGS available. Okay, I think this is just a question for the event organizer. Yes, we're going to be recording all of this, Jose. Yeah. Great. So with that in mind, I'll just compare the releases side by side. 7.0 VCF only, so you did have to have VCF, you had an NSXT and all of that good stuff, but you got the whole shooting match there. You got the pod VM support, you got the Harbor image registry. 7.0 U1, you can still deploy this with NSXT. If you deploy it with NSXT, you still get pod VMs, you still get the Harbor image registry, but the other option is to use the HA proxy as a load balancer service and not use NSXT. The thing to bear in mind there is that if you don't have NSXT, you can't have pod VMs and you can't have the Harbor image registry. In 7.0 update 2, you can choose to have NSXT, and then you get everything again. You can choose to have the HA proxy, and you have the limitations that I just described, but there's now a new load balancer, the NSX Advanced Load Balancer. And the big difference between the HA proxy and NSX Advanced, I would say the NSX Advanced is more production ready. It's got a nice UI interface. You can see a lot of consumer-like information, like who's consuming load balancer IP addresses, and all of that good stuff is inside in the NSX ALB. Whereas the HA proxy is a bit more, it's a bit more lightweight, I guess. It doesn't have any sort of UI or anything like that, so it's a bit difficult to figure out, you know, where things are being consumed from. The other big difference with the HA proxy, it's not a VMware product. So the HA proxy is an open source product that we've used, and we've done some engineering work on that. So support stops at the load balancer service. So in other words, we will support you from the load balancing service perspective, but anything else to do with the HA proxy is really not a VMware responsibility. So that the support is a little bit something to be considered when you're using the HA proxy, whereas the NSX Advanced Load Balancer, which is also included with vSphere with Tanzu, by the way, it's not a separate product, that's fully supported VMware stack you would have with that. So something to bear in mind. I'm not going to go through all the requirements. There's quite a number of them there, but they're all called out, and you'll see in the demo shortly where they're all called out. So I'm going to go through the HA proxy deployment now. So this is my environment, and the HA proxy can be deployed in two ways. It can be deployed with a combined workload front end load balancer network. In other words, those two networks are the same physical media, but different segments maybe on it. But more commonly, we have it deployed out with 3 different networks, where the front end load balancer network is separated from the workload network. So when we go ahead with the deployment, it comes as an OVA. We just fill it all in. You decide whether it's a 2-NIC or 3-NIC OVA that you're deploying, depending on whether the front end is co-located with the workload networks, and you just fill in all the details. So a few things to consider about the networking here. There are a number of network ranges that you need to provide. Obviously, it's going to be providing a load balancer service, so you give it a range of load balancer IP addresses. also, it keeps track of IP addresses that are used on the management network and the workload network as well. So these are the different ranges that you have to set aside. Like I said, the load balancer is fairly obvious. When you deploy the supervisor cluster, we mentioned that it's 3 virtual machines. Those 3 virtual machines each need to get an IP address. There's also an IP address set aside for the etc daemon, which is the key value stored that's used inside in the supervisor cluster. And also there's a 5th IP address used for rolling upgrades, because you can do a rolling upgrade of the cluster when new versions appear. The last range of IP addresses that you need to set aside are workload network IP addresses. And these are used also by the supervisor network, but predominantly used by the guest cluster nodes. So this is where the guest cluster node virtual machines get plumbed up onto. So you need to set aside those 3 distinct IP address ranges before you start with enabling vSphere with Tanzu, or even deploying the HA proxy. So anyway, there's 2 tools that I use all the time when I'm deploying the HA proxy. One of these is just to let me know whether the range of IP addresses matches a particular CIDR that I want to use, or CIDR format, because what you find with the HA proxy deployment is that it's a combination of IP address ranges, and it uses CIDR from time to time as well. So you just need to make sure that those 2 match up, and that's why I use that IP address guide there. On the other tool I use all the time is this thing called an IP scanner, because basically when the HA proxy has been deployed and you've given it its range of load balancer IP addresses, all of those IP addresses should respond to a ping request. And so I use in fact the Angry IP scanner. It's a great name, but that's the one I use. And what should happen is that when I run that on the segment of the network where the load balancer range resides, I should get responses from all of the IP addresses, and that lets me know that the IP address is responding and the HA proxy is working correctly. I think there might be a question there. It's possible to mix the additions, VCF for production environment, vSphere with Tanzu development environment. So I guess that question is whether you could have NSXT and whether you could have the load balancer appliances. I believe the answer, Alan, is yes to that. And so you would have separate clusters, obviously. So you would have distinct clusters. It's not something I've actually tried, but I think as you set up the cluster, it does actually prompt you whether you want to use NSXT or whether you want to use the distributed switch and a load balancing service. So my understanding is that you should be able to try them out individually. Not something I've tried myself, but I can't actually think of a reason why it would not work. So hopefully that answers your question. Great. So we've said now we've gone ahead and we've deployed out the HA proxy, and it's gone on to it's the 3 NIC configuration. So we'll have one uplink on the management network, obviously. We'll have a link to the workload network for the supervisor nodes as well as the TKG nodes, and then there'll be a link to the front-end network, and that's where the load balancer service is providing the IP addresses. Again, it provides them for the supervisor cluster, provides them to the TKG guest clusters, but also any applications that you deploy in either of those clusters that requires a load balancer service. Now, as I said, stick the Angry IP scanner on there after that and let it verify for you that it's all working. There's a final test you can do. The HA proxy uses port 5556, so you should be able to point the browser at that, connect to it, log in with the credentials you provided during the OVA deployment, and it should start responding with some useful metadata descriptions there. So that's just validating for you that it's all working correctly. Alrighty, so let's get on then with deploying vSphere with Tanzu now that we have the HA proxy set up. And this is just coming back to the question that was just asked there about selecting a network stack. You can see there that if you had NSXT, you could choose that. But if you just wanted to use vSphere distributed networking, you could use that as well. And that's what's selected there. So I'm not going to go through all of the screenshots. We have a short demo to show you, but essentially what should happen is the 3 supervisor nodes get deployed. And once they're deployed, it should be able to reach out to the HA proxy for a load balancer front-end IP address. And when everything is successfully configured, you should see that the load balancer IP address comes in place there for the workload management section. And again, workload management is vSphere with Tanzu. You just don't see the vSphere with Tanzu reference in the UI. We call it workload management for some reason. Now, assuming that this is all gone according to plan, and I've enabled vSphere with Tanzu / workload management, I should get the 3 supervisor nodes on the management network, but also on the workload network. So they're multi-homed. And then last but not least, I should get a supervisor control plane API server IP address that is provided by the HA proxy load balancer on the front end network. So let's have a little demo to see all that in action. So this is my vSphere environment. You can see the new workload management and all the requirements are listed there. This is going to use the distributed networking because I'm using a HA proxy. You go ahead and you select which cluster you want to enable it on if you have more than one cluster. And then, as Frank mentioned, this is where you decide on the sizing of the control plane VMs. I'm just going to go with small here. Next thing to do is select a storage policy. Because I'm building it on vSAN, I'm just going to pick the vSAN default storage policy. And now we start getting into providing the first of the 3 networking configurations. This is for the load balancer network. So we need to tell it all about the HA proxy because the HA proxy is what provides the range of IP addresses. You can put the range of IP addresses there. And this should match back to what you provided when you set up the HA proxy in the first place. And just put a certificate then to secure communication to the HA proxy. The next network, the management network, this is the one used by the supervisor cluster virtual machines. So this is the range of 5 IP addresses, and you give it the first starting IP address on your management network. And it has to be on the management network because the supervisor cluster talks to vCenter server for various things. And the rest is just usual networking information. Populate all that like so. Now we come to the final network range that we talked about previously, and this is for the workload network of the TKG guest clusters. Now, it's not just the TKG guest clusters that need this, it's also the supervisor. So there'll be 3 IP addresses for the supervisor used in this range, but the rest of them will be allocated to 2 TKG guest clusters for the virtual machines that make those up. So once that's been added, that's the 3rd and final network configuration. The next one that we add, the next configuration step, is content library. And this content library is a subscription content library that has all of the images for our TKG guest cluster nodes. So you can choose which version of Kubernetes. You could have multiple different guest clusters deployed. So we can speed things up. Fortunately, we don't have to hang around for all of this to roll out, but we can see the namespace object or resource pool being built there, and the 3 supervisor VMs are coming up. And like I said, they should have an interface on 2 networks, the management network and the workload network. And there should be an additional IP address on one, which we can see there. And that additional IP address is for the etcd key value store. So it looks like we've 1, 2, and 3rd one, yeah, we're still waiting for that one to come up, but it's almost there now. Filippo asked a question. Yes, it's only distributed switches, Filippo. You can't do this with standard switches. You do need a distributed switch. Great, so you can see it's got its control plane IP address. We're now going to create a namespace. And Frank has talked to us in detail about how to do namespaces. It's pretty straightforward. You just select the name or the cluster, you give it a name, you select which network. Workload network, you can have multiple workload networks defined actually and separate out your namespaces and clusters that way. You can get the tools for your developers here. You can see this URL that I just connected to. You can download all the kubectl tools. Your developers can download them to interact with the namespaces and the clusters within the namespaces. You can assign the storage that is allowed to be consumed by anything created in this namespace. And as Frank has showed us, we can go through all the limits and so on and so forth here as well. Make sure developers don't step on each other's toes. And we don't have any guest clusters created yet. The content library is linked for the guest cluster images, but shortly we will go ahead and create a guest cluster, but we don't have any created just yet. So that completes that demo, and we saw the namespace being created. So just a little bit more about this, and I know I'm probably just recapping on what Frank has done, but these are all the different things that you can control through a namespace. And as I said, it's almost like a multi-tenancy resource management feature that it just allocates a certain amount of resources to a particular developer or team of developers. But you have all the information needed there around the namespace. Now, we showed the URL where developers can download tools. This is one of the tools, is the kubectl vSphere, which allows you to log into the cluster. And once you're logged into the cluster, you can do various things like build objects, whether they're pod VM objects or whether they're cluster objects or whatever. Obviously, because this is using a HA proxy, we can't do pod VMs. Remember, that's a restriction of using the HA proxy. You need NSXT to build pod VMs. Should namespace a DNS entry of the main control? No, it's just the naming format. So that message is a little bit misleading that we saw on the namespace about it. Just means that the naming convention can't have any characters that are strange. So basically they need to adhere to DNS, the DNS naming convention, essentially. So you can't put like @ symbols and percentage symbols and those kind of things. That's all that meant, Gabrielle. So yeah, you can change context. You can see that I have a namespace here, the Cormac-NS namespace. And you can work in that namespace. But what I'm particularly interested in doing, and this is the major use case as well, is the ability to build a guest cluster. So you can see here that I have a very simple manifest file. This is Kubernetes 101. Now, manifests are written in YAML, yet another markup language. And it's basically, this is what we pass off to the Kubernetes API server to request it to create something or do some action on our behalf. So this is a very simple one. It's a request to make a guest cluster of kind Tanzu Kubernetes cluster that has one control plane VM and 2 worker nodes. The distribution, the Kubernetes version, is 1.17.8, and that needs to exist in your content library, which you're obviously synchronizing back to VMware to get all of those images. So 1 control plane, 2 worker nodes. Frank talked to us about the class, the node resources. These are guaranteed small nodes or VMs that we built. And then this is the image library that we're going to use. And so what should happen in that particular case is that request goes to the supervisor control plane, and it is responsible for building out 3 new VMs of a single control plane and 2 worker nodes. They're all on the workload network. That's where the worker nodes are placed. And of course, the load balancer service plays a role here as well, because you always use a load balancer front-end IP address to talk to the API server. Doesn't matter that it's just 1 node, but the point here is that these guest clusters could be 1 control plane node, 3, even 5 control plane nodes, depending on the size of the cluster. But you'd have a single front-end API server load balancer address to communicate to those. And then the worker nodes, I just selected 2, but of course you could have way more than that, depending on the number of applications and the size of applications that you're running in that cluster. So just to show you how things change slightly now, so we can work in the context of that guest cluster and create, upstream container images and all of that good stuff. There are 2 additional commands to the login, and it drops you into the context of the guest cluster, so that now everything that you run from a kubectl perspective in here is not going to the supervisor cluster, but is now going to the guest cluster. And that's how we can switch contexts. So I have a short demo here as well. We've previously built our namespace, and now the objective, there's nothing used currently in the namespace. The objective now is to go ahead and build a guest cluster. So I'm going to use that kubectl vSphere login that we talked about. I'm going to connect to the API server of the supervisor, which I've done there. And if I look at the context, I'm currently in the context of the namespace Cormac-NS on the supervisor cluster. Okay, so let's look around. You can see the nodes, 3 supervisor nodes, 3 master nodes at the moment. I don't have any virtual machines, but I do have all these virtual machine images that I can use. And you can use the shorthand for those. You don't need the full name But again, the virtual machine classes are available to me, and Frank has talked to us about those. So I have this manifest file already created. It's slightly different from the demo that we talked about in that this one has a worker count of 3, and it's using a different distribution of Kubernetes. Now we can query each of these classes, and you can see how much hardware from a CPU memory perspective is being consumed there as well. Custom classes is something that's coming soon. I don't think we can do it yet, David. So I'm going to apply this guest cluster and leave it do its thing. And yeah, so we have various ways of monitoring it. There is a cluster object that we can query, but obviously it hasn't been created yet. There's also a Tanzu Kubernetes cluster, and we can see that it's in a phase of creating now. And the cluster, yeah, the cluster is now come in and it's been provisioned. So we can actually watch things happening now in the UI. Gives the vSphere administrator full view into what the developer is doing from, the creation of these guest clusters and what size they are and so on. We can use the describe command. It's another kubectl Kubernetes command to see where things are going. There's a lot of information that still needs to be populated here. So this is very early stages of deploying out the cluster, but again, we can speed things up, and you can see all those add-ons. These are all basically the plugin drivers for Kubernetes all being added in here for storage and networking now as well. The nodes are still in a pending state. They haven't come online yet, but now I can get the virtual machines. I can see those virtual machines being listed there as well. So we have a lot of useful information in the supervisor to actually query what's going on in the guests. It looks like we're almost up and running now. We can see the single control plane node. We could also see the 3 worker nodes. And then you can see that there's some considerable resources now being used in the namespace. So great. So it is more or less ready. So that means the guest cluster is up. So what I'm going to do now is I'm going to change contexts. I'm going to log out of the supervisor context and use those additional command line arguments. That allows me to log into the guest cluster that I've just created. And so that just means that the developer, when they start building applications, they're going to be building those applications against the guest cluster and not the supervisor cluster. So again, I can get the contexts, see what context I'm working in. I'm now working in the context of the supervisor. So you can see that there. So I can just look around looking at the nodes. It should be 1 control plane, so 1 master and 3 workers now, whereas previously when we were looking on the supervisor, it was 3 master nodes. So as I said, anything that the developer does now in this environment is against the guest cluster, and so they can use upstream container images and build services, build stateful sets, deployments, all of that good stuff that they need to do within this context. Okay. So the last thing that I wanted to talk to you about was DPP, the data persistence platform that is available since the VCF 4.2 release, which I think was just a month or 2 ago. So the whole idea here is that we can have services available within our vSphere with Tanzu that might be useful to your developers or teams of developers. So for instance, you might create a namespace with a Tanzu Kubernetes grid guest cluster for one of your development teams, and they come to you and say, well, actually what we need is an S3 object store. And so what we've done is we've partnered with Minio, Cloudian, and also Dell EMC to provide on-prem S3 object stores that can be allocated on a per namespace basis to your developers or teams of developers. So you as the vSphere with Tanzu administrator would set up this service, and then you would provision instances of the service on a per namespace basis. Now, at the moment, it does require vSAN. So you can provision these onto vSAN, but there is a new vSAN configuration called vSAN Direct, which allows you to provision these directly onto standalone native devices that are available on the ESXi hosts as well. So the reason behind that is because vSAN would typically do its own protection. So we do RAID 1 mirroring or RAID 5 or RAID 6 or something like that. But many of these applications, in fact, all of these applications have their own built-in replication. So the guidance here is, well, if you want to use the built-in replication of the application, you can deploy these onto the vSAN direct configuration, which is, no protection at the vSAN layer, but protected in the app. Or if you prefer to have belts and braces, I guess, protected in the application, but also protected at the infrastructure layer, you can provision it directly onto your standard vSAN data store. So as I said, available with VCF 4.2. At the moment, Minio and Cloudian are available, and the Dell EMC ECS, the Elastic Cloud Storage S3 product, should be available very shortly. Okay, hopefully I didn't overrun too much. There were quite a few questions. Hopefully I've answered them all, but I'm going to be around for the rest of the session while Duncan is doing his presentation, and I'm more than happy to take any more Q&A there and maybe add some more elaborate.
We have one outstanding queue.
Yeah, to define custom classes question. Yeah, so that I think I mentioned it's not in the product yet, but my understanding is that it is something that we will be bringing shortly to the product.
Oh, thank you.
I hope that's okay. Okay, I will stop sharing and I will allow Duncan to share, but I think we might still have a minute or two if we want to have any more Q&A in the meantime.
Sure, we can wait.
Yeah.
And if there are no questions, we can also get started. So,
yeah, I think you can get started. I'll just, if there's any further questions, I'll deal with them offline. Yeah.
Sure. Let me make sure I have the chat window open. Again, as Cormac and Frank also mentioned, if there are any particular questions, feel free to ask them in the Q&A window. I will have the Q&A window open as I go through the deck, so I should be able to answer most questions on the fly. Now we've seen the session by Frank and by Cormac, and I think it's pretty obvious that the focus for VMware, but not just for VMware, but for the industry as a whole, is trying to start moving to these newer types of platforms. Now, having said that, of course, when you try to move to a newer type of platform, from an application perspective, it still means that these solutions will need to land on top of some type of infrastructure. And that's where the focus of my part of this roadshow is going to be, on the infrastructure aspect. And more specifically, I'm going to focus primarily on the storage side of things, because I think it's something that is often overlooked by a lot of customers, but it's really important because a lot of these cloud native workloads, although a lot of people will tell you that these cloud native workloads are supposedly stateless, reality is that a lot of these cloud native workloads actually need to store some form of state somewhere. And that's where vSAN then typically comes into play. Now, when you look at the infrastructure itself and you compare it to what we've seen in the past, I think it's funny that, in the past, people have always spoken about these three-tier architecture type of solutions as being legacy solutions, where three-tier architecture solutions referring to, for instance, three-tier application architectures where you have a front end, an application server, and a database, or maybe the infrastructure where you have networking, storage, and compute as isolated units. Now, the funny thing is that if you look at the infrastructure that is presented to presented for these cloud native applications, these three layers actually start coming back. Not, from the aspect that we've just discussed, but it's slightly different, being that if you look at it from a persona perspective, we again have three layers. Although these three layers are a bit more complex because we have many more components that are part of it, they are still presented to, distinct personas. Frank primarily addressed the developer aspect of things. So the developer accesses the TKG clusters, the Kubernetes clusters, and actually deploys its applications that it's developing within the Kubernetes environment. And then, of course, there's the Kubernetes infrastructure as well that needs to be managed by an administrator. This is typically the DevOps team or the SRE, or, some of you may have a different name for the role, but you'd understand what I'm getting at. And then last but not least, this is typically the rest of the infrastructure that sits underneath what the majority of you will probably be responsible for. And that is, in most cases, going to be vSphere plus networking and storage, and hopefully that storage is going to be vSAN. Now, for those who haven't heard about vSAN yet, I'm just going to give a brief introduction of what it is and what it does, and then we'll start looking into some of the individual features that we have available, which I feel make vSAN extremely unique compared to other storage platforms out there. First and foremost, vSAN is an enterprise level storage solution, which has been incorporated straight into vSphere. So if you're one of those customers which is already using vSphere in any shape or form, and you know how to manage or enable HA and DRS, you will probably also be able to configure vSAN. That doesn't necessarily say that is as easy as vSphere HA is, for instance, which is a single option to enable it, and you've got a couple of configuration options. There's of course more that comes into play when it comes to deploying vSAN, but the management aspect happens from vSAN to server, and it all happens on the cluster level. As soon as you enable it from a cluster level, what we will start doing is we will start looking at every single host which is part of the cluster. We will see if there are available devices, those devices being flash devices, and that could be SAS, SATA connected or NVMe connected, or if there are any spindles available. If we have those devices available on those hosts, we will create a single large logical data store out of it, and we will present that logical data store to all of the hosts within the cluster. Now, as soon as you've done that, I think this is where the interesting thing comes into play when it comes to vSAN specifically. Of course, when you have this data store available, you will want to start deploying virtual machines or maybe containers or potentially even file shares or iSCSI LANs or whatever it ends up being to your vSAN data store. Now, the way you go about doing that, of course, is through the vSphere HTML5 user interface, or of course, you could use the API as well, or things like Power CLI or whatever it ends up being. But the important part here is the following. As soon as you've created, or as soon as you create a virtual machine or any of the other types of objects, you typically assign a policy to it. After you've assigned a policy to it, and that policy could specify different capabilities, availability, performance, maybe an IOPS limit, vSAN is going to take care of the placement of that data. So it's going to ensure that the data is going to be placed within your environment based on what you've specified. So what does that mean, and what does that look like? Well, when you deploy a virtual machine on top of vSAN, I think it's first of all important to understand that vSAN is a distributed object store. A virtual machine or a virtual disk is something that we refer to as an object. If you specify within policy that you would like to have multiple copies of the data, you will have this object, and that object will consist of multiple components. Those components are the copies of the data. So in this particular case, as you can see on the diagram, we have 2 full copies of the data, and we have a witness component, which basically means that within the policy, we've specified that this should be a RAID 1 configuration, and we should be able to tolerate a single host failure, or a single failure is probably what I should be saying. If anything fails within this environment, of course, the other copy of the data is still available. Plus, we also have the witness available to determine who owns the data. So we have that capability available within vSAN. Of course, we could do RAID 5, RAID 6 as well, if you prefer that over RAID 1 mirroring, because RAID 1 mirroring is a full copy of the data, where with RAID 5 and RAID 6, we're actually leveraging the parity capabilities, so it has a lot less overhead. Now, that's for the policy part of things. Of course, there are a couple of other things that you could do with vSAN as well. You can, for instance, enable particular data services, not just on the virtual machine level, so RAID 1, RAID 5, RAID 6, or maybe multiple copies of the data when you have RAID 1. But on top of that, you can also enable different data services on a cluster level. Those data services are things like deduplication and compression, data at rest encryption. You could potentially start creating file shares, or you could create, for instance, the vSAN iSCSI target service. Now, for those who haven't seen it yet, with vSAN 7.0 Update 1, we've also introduced compression only specifically, and we've introduced data in transit encryption. Compression only is mainly targeting those customers who are running workloads which wouldn't benefit from deduplication and compression, or those customers who don't want to incur the potential performance overhead or resource overhead that deduplication had, because deduplication typically comes at a larger overhead than, for instance, compression. So that is why we've introduced those services. Again, those services are enabled on a per cluster level. So on a per cluster level, you can specify that these services need to be enabled. Now, when you've enabled those services and you've created these policies, the other thing that we've also have available within the UI is the ability to specify what your data center looks like. If you have a single data center room, for instance, but you have multiple racks and you perceive these multiple racks to be, those racks to be a single point of failure, or maybe you have a chassis or multiple chassis and you perceive those chassis to be a single point of failure, or maybe even you have multiple data center rooms within the same building, you could specify within the vSAN UI that you have these different fault domains. And now when we start creating these objects and vSAN needs to place those components, it's going to ensure that the data is spread across those fault domains. Again, those fault domains could be racks, they could be rooms, they could even be buildings within the same location, or we could even create a stretch cluster for that matter. When it comes to data placement, vSAN will take care of that automatically, and it will ensure that if one of those fault domains fails, the virtual machine or the VMDK is still accessible by whatever or by whomever would like to access it. So we have that capability available within the vSAN UI as well. And it's extremely easy to set up, and it's also extremely easy to create a cluster. Just let me show you what that looks like. So what I'm going to do in the next demo is I'm going to create a stretch cluster configuration. And it literally takes a few minutes. In this particular case, I already have vCenter up and running. I have a bunch of hosts sitting within my virtual data center. And of course, what I now will need to do is I will need to create a cluster. So I'm going to go to my virtual data center. I'm going to click new cluster. I'm going to give the cluster a name. And then, of course, what I'm going to do is I'm going to enable the options that we'd like to have enabled on this cluster. Those options in my case are going to be DRS, HA, and vSAN. And then when I click finish, it's going to take me automatically to the quick start wizard. Now, the quick start wizard then will enable me to quickly not only add hosts to a cluster, but also configure those hosts. And for instance, configure additional data services as well. So I'm going to simply select the hosts that need to be part of this cluster. I've selected 4 of them. I'm going to click next, next, finish. Those hosts will be added to the cluster automatically. And then it will take me to the next step where I could actually start configuring the different services. Now, in my case, those services are going to be stretch clustering. So I will show you what that looks like. Now, of course, before we do, we need to make sure that we've passed all of the different tests that you see at the add host section. All of those tests actually look okay. So we're going to go into the next section. I am not going to enable or configure the network. Well, the network is enabled, but I'm not going to configure it because I've already done that. But I'm going to focus on the stretch clustering aspect. So I've just selected the deployment type stretch cluster. And this is literally more or less all that it takes to create a stretch cluster. The only thing that I will still need to do is define which hosts are part of which building. So these are my 2 buildings. And then after I've done that, I need to make sure that I select a 3rd building as well, where my witness host resides. So this is the witness, basically the quorum mechanism. If anything happens to the network, we can use the quorum mechanism to determine or figure out who owns the data and who has access to the data. So now the cluster is going to be created automatically. And that is literally all that it takes to not only create a vSAN cluster, but create a stretch cluster across 2 buildings and assign a witness to it as well automatically. So literally within, of course, I sped up this part of the video. There's no point in waiting for OVS to be deployed. But it literally takes a couple of minutes, maybe 10 to 15 minutes before the cluster is created. That would even still be the case if I would have enabled, for instance, something like compression only deduplication. The process by itself is rather fast. Now, of course, after I've done this, I could start leveraging or start deploying virtual machines. I can look at the vSAN interface to figure out what the environment looks like. As you can see, we have these 2 fault domains that we can start leveraging, and it actually shows me the witness host as well in the environment. Now, that is what it takes to configure vSAN stretch clustering. As I've already mentioned, it's pretty straightforward. Now, of course, there's a couple of other things as well that comes into play when it comes to deploying an HCI solution. with HCI solutions, I think one of the biggest benefits that it brings you is the way that you can actually scale an environment, especially if you compare it to traditional storage systems. With an HCI system, of course, you can add disks or flash devices to a host or to multiple hosts within the cluster. You can add many disks, disk groups in our case, as we refer to them, to hosts within a cluster, or you can even add hosts to a cluster to scale up or scale out your environment. The other thing that we've now introduced as part of vSAN 7.0 update 1 is the ability to start mounting vSAN data stores across vSAN clusters. So starting with vSAN 7.0 update 1, we've introduced a capability called HCI Mesh. And basically what HCI Mesh allows an administrator to do is to mount a data store remotely. So we have a vSAN cluster, which is the one at the bottom, for instance, which has a massive amount of disk capacity available. And we would like to share that disk capacity with the 2 remote clusters. Well, we can simply do that by mounting that remote data store and then start deploying or provisioning my virtual machines on top of them. Of course, that brings the added benefit is that if we have everything cross-connected, we can now also start vMotioning between clusters because we have that connection between those data stores available. Now, what I've mentioned was that we could do this for vSAN-based clusters, but what we introduced as part of vSAN 7.0 update 2 is also the ability to do this for non-vSAN clusters. So if you're one of those customers that has a few vSAN clusters with a massive amount of storage capacity still available, but you have some compute-only clusters which have little to no storage capacity available, you could potentially enable vSAN on those clusters as well, and then connect from that compute-only cluster back to that vSAN cluster and start consuming all of the capacity, but of course also all of the data services that are available within that environment. So if, for instance, it's an all-flash configuration and it provides the ability to RAID 6, for instance, and you only have a 2-node compute cluster, you can still leverage that RAID 6 capability because that is actually something that you're leveraging remotely. So I think that is something that is truly unique that was introduced for vSAN 7.0 update 2 as well. The other thing that we've introduced with 7.0 update 2 is the ability to specify within the policy which data services, things like encryption, deduplication and compression, or compression only, or all flash versus hybrid, which of those data services should be available on the data store where you're provisioning your virtual machine to. And this is something that we've introduced specifically now that we have the capability around sharing these data stores, so HCI Mesh, because as you can imagine that if you have multiple types of data stores, some being all flash configuration, some being hybrid, some having compression enabled, others, for instance, having encryption enabled, that when you provision a virtual machine and you would like to leverage the capabilities like for instance, or the capability like for instance encryption, you have that selected within the policy, that this then should present only the data stores which have encryption enabled. So this is also something that we've introduced as part of vSAN 7.0 update 2. Now, of course, I created a demo for it. In the demo, I'm actually going to show you how you can mount a remote data store when you have a compute-only cluster. And I think it immediately shows you how powerful and how easy it is to configure. In this case, I have a vSAN cluster, as I mentioned. It already has vSAN enabled. And what we're going to do next is we're going to go to my compute-only cluster, which in this case is a 2-node configuration. It could also be a single node, by the way. And what we're going to do on that 2-node configuration is we're going to enable vSAN. Now, when we enable vSAN, we need to select that we're enabling it for the HCI Mesh compute-only capability. This then is going to load the vSAN client on those 2 hosts within that cluster. After the vSAN client has been loaded, what we can then do is we can mount a remote data store. So we can mount the data store of the vSAN cluster to my compute-only cluster. So I'm going to go ahead and click Mount Remote Data Store. That is going to take me to the Remote Data Store wizard. I can then click Mount Remote Data Store again, and I can actually mount that data store. So I will select the Remote Data Store, click Next, Next, Finish. And then the data store is going to be mounted to my compute cluster. And as soon as it's been mounted, we can start consuming the capacity that is available on my environment. Now, there are a couple of health checks that we are doing. just to ensure that you're not exceeding any of the limitations that are support limitations that are in place. If you're not exceeding those, of course, the data store will be mounted, and you can, when you provision a virtual machine, you can now simply select the data store that we've just mounted. Of course, we can select, the data store that we just mounted, but if we would have multiple data stores available and we would select a policy, only the data stores that would adhere to the policy that I've selected would show up. So we have that ability available as well. If you have 4 data stores mounted, you can simply select the policy, and then of course the virtual machine will be provisioned to the data store, which meets all of the requirements that you've specified within that policy. So I think that is something which provides a lot of flexibility for customers as well. Okay, besides of course being able to mount the data store, you can also see where virtual machines are provisioned. And as I've already mentioned, we also made a couple of changes from a policy perspective. So if we create a new policy, you now have the ability to specify within the storage rules section which data services should be enabled. I just showed it in a screenshot 2 slides ago, but I just wanted to make sure I would show it to you in a demo as well. You can simply select the data services that should be enabled. And after you've selected the data services that should be enabled, when you then provision a virtual machine, only the data stores, in this case that have data address encryption enabled, compression enabled, and are all flash, will show up as a compatible destination for my virtual machine. So we have that ability also available within the UI. So hopefully that makes it clear, not only how easy HCI mesh is to configure, but also how flexible it makes virtual machine provisionings, especially in larger deployments where you potentially have a lot of spare capacity in various clusters out there. Now, there are a couple of considerations. I'm not going to go over each of these. The slide deck will be shared, and I think the recording will be shared as well, so you can look back at this slide in particular. I think there are probably 2 things that I should mention. First of all, a single data store can only be mounted by a maximum number of 128 hosts. So that is the current limitation that we have in 7.0 update 2. In 7.0 update 1, for customers who are still running that, this limitation was 64 hosts. So we doubled it with 7.0 update 2, but it could still be a limitation if you're one of those customers that has hundreds of hosts, dozens of clusters in their environment. The other thing is that a client cluster can only be mounted by a maximum, can only mount a maximum of 5 remote data stores. So you can't create this extremely large mesh just yet of hundreds of different clusters. You can imagine that this may be something that we will be able to provide to you in the future, but that's not something that is possible today. So those are things that you need to keep into consideration. The other thing, of course, to keep into consideration is to ensure that you have a high bandwidth, low latency network connection between the hosts and between the clusters as well, because that will determine the performance from a storage perspective. So that is something to keep into consideration. Now, we've just discussed how to create a cluster, how you potentially could scale out resources or provide resources to other clusters in your environment as well. And of course, then there are also a couple of other ways of leveraging vSAN storage. One of the things that Cormac has already discussed, and this is also one of the things that Frank has discussed, is that when we deploy these cloud-native workloads, that cloud-native workloads typically will need to store some kind of state somewhere. And this is potentially where, for instance, vSAN file services can come into play. It's not just, of course, intended to store, container state. Of course, you could also use it by connecting Windows clients or Linux clients to it. And that is one of the reasons we've introduced support for both NFS version 4.1, version 3, as well as SMB version 2.1 and version 3. And we've also introduced support for authentication, specifically Kerberos for NFS and Active Directory for SMB. Now, we've introduced this capability with vSAN 7.0 with NFS, and then with 7.0 update 1, we've actually expanded it with SMB. So depending on which version you have, you may or may not see certain protocols to be available. Now, I'm going to explain some of the different concepts in this diagram later on with a different diagram. So I'm going to skip to the next slide for now. Well, one of the questions, of course, when we first introduced vSAN file services that popped up immediately in Europe is this also supported for 2-node configurations and or stretched cluster configurations? Unfortunately, before 7.0 update 2, that wasn't supported, but starting with 7.0 update 2, we now do support stretched cluster configurations. And I'm actually going to show you how you can configure that in a demo within a few minutes. Now, one of the other things which also may be interesting for those customers who are looking for a more secure environment, we're also supporting data in transit encryption. Of course, data at rest encryption was already supported, but now data in transit encryption is also supported for vSAN file services. Now, those wondering what the snapshot reference is on this particular slide, we also have the ability to create snapshots and extract the differences between 2 different snapshots. So these capabilities are available through the APIs and are primarily intended for our backup partners. So partners like, for instance, Veeam, Commvault, and all of the others out there, Dell EMC, are now working on solutions that will natively work with vSAN file services as well. Of course, solutions like Veeam already had an offering that worked seamlessly with vSAN file services, but hopefully by providing these APIs to them, they will be able to enhance their solution even further. Now, if you look at how it has been implemented, and this is what I was just referring to, it has been implemented slightly differently than we've seen so far. So if you have an NFS or an SMB client and an NFS or SMB client connects to an NFS or an SMB server, of course, that NFS or SMB server needs to run somewhere. In our case, of course, that's going to run on top of vSphere. Now, as you may recall at the start, I said that vSAN has been tightly integrated with vSAN. Now, this is also tightly integrated with vSAN, but it has been implemented in a slightly different way. The way we've actually implemented this is by instantiating the NFS or SMB service as a container that runs within a file services virtual machine. Now, that is the case for now. And I'm saying for now, as this may change over time. As you can imagine, one of the things that we've discussed in the previous sessions was the ability to run containers natively on top of vSphere, where you can imagine that over time, the file services VMs will disappear, and these protocol stack containers that run NFS or SMB will run natively on top of the vSphere layer. Now, when you deploy or when you create a vSAN file share, of course, you will need to associate a policy with it. And then, of course, as soon as you've associated a policy with it, or you've used the default policy, what is going to happen is that these components are going to be created by vSAN itself. And those components are going to be formatted with a virtual distributed file system. That is the VDFS layer that we refer to here. Now, one of the questions that you may have is, okay, that sounds great, but what about the efficiency of this solution because it's not running natively within the hypervisor? And that is where the middle part of the diagram actually comes into play. In the middle, it actually says vSocket/VMCI, and that is an interface that is part of the file services VM, which allows us to directly communicate with the hypervisor layer. So the file services virtual machines or the protocol stack containers have the ability to directly communicate through that PCIe device with our kernel modules. So that is something which is unique to vSAN file services, and I think provides us, competitive edge as well over other types of solutions, and allows the solution to be extremely efficient and performant on top of that. Now, what I've done in this particular demo is I've set up a stretched cluster configuration. So I already have the stretched cluster configuration up and running from a vSAN perspective, but I don't have vSAN file services running yet. So I've created these 2 fault domains. All of the hosts which are part of the 230 range are part of my preferred fault domain. The hosts that are part of the 240 range are part of my secondary fault domain. And this is important when I start creating my file services environment, because what I can do when I create my file services environment is I can bind a particular file share and the IP address over which I access that file share to a particular location as well. So the first thing I will need to do when I enable vSAN file services is create a vSAN file services domain name, where this is basically a namespace. And then what I will need to do is I need to specify the DNS server and the DNS suffix. Of course, after that, I will need to make sure that I can connect things to the network. So I'm going to select a port group. I want to point out here something here is that port group I would highly recommend that it's going to be a dedicated port group for vSAN file services. I simply selected my VM network, but in the case of a production environment, please create a dedicated port group for vSAN file services specifically, because as soon as you select this port group, what is going to happen is that promiscuous mode and forward transmits are going to be enabled on the port group itself. So that could be a security issue for other virtual machines. So please make sure you have a dedicated port group for that. Now, after you've selected the port group, of course, you need to fill out the subnet mask and the gateway for the network that it's connecting to. And then what you will need to do is you will need to start adding IP addresses for the file service instances that are going to be deployed. These IP addresses are going to be used by the container, not by the virtual machine, but by the container itself. And this is also the reason promiscuous mode and forward transmits need to be enabled, because we will have a different MAC address for the container that we have for the virtual machine. Of course, a DNS name would be preferable. And then the next thing that we are going to do is we're going to select a site affinity for each of the IP addresses. And this is the IP addresses through which we will access the file share. So some IP addresses will be will have site affinity with the preferred location. So they will end up being hosted in the 230 range of my hosts. And then the secondary the IP addresses that will have affinity with the secondary location will end up being hosted on the 240 range of my environment. Now, of course, after I've filled everything out, I click next, finish, and my file services virtual machines are going to be provisioned. The containers are going to be instantiated. The containers are going to be configured. And of course, we will make sure that the affinity is correct as well. This basically will then allow us to create a file share. And after we've created, or when we create a file share, we can specify with which location the file share should have affinity and if the data should be replicated across these locations on top of that. Now, let me show you what that looks like. So we're going to click file share, and then we're going to click add. And when we click add, we can simply create a file share. This could be NFS or SMB. In this case, I'm just going to create a simple NFS file share, and it's going to be stretched across locations, but I would like to access it primarily in the preferred location. So the affinity site, in my case, is going to state preferred. The storage policy was stretched. So if for whatever reason, the complete preferred site fails, the data will still be available and the site or the NFS share is still going to be accessible through the IP address. It's just going to be running in the secondary site temporarily, but as soon as it returns for duty, the site returns for duty, those services are going to migrate back to the location. Now, of course, you may want to use this in case, for instance, you are running workloads within the preferred location, and you would like to avoid the situation where you have data actually traversing the intersite link between those two sites. So that is why you would, for instance, use this capability within an environment. Now, if you don't need the capability, of course, you could say, instead of specifying site affinity, you could say either, and we could use either of the two locations. And that could be something that you may want to do when you have a low latency connection. Now, when you've created the site, or when you created the share, sorry, you can, of course, look at the placement of the data, whether it's stretched across locations or remains within a single location. Of course, when there are workloads running against this particular environment, we can click on performance and look at the performance details, etc., as well. But this is basically all that it takes to create a vSAN file services environment on top of a vSAN stretch cluster configuration. Now, the last part that I want to show you is something around management of workloads. And this is something that we've introduced not too long ago. In Semverdo Update 1, we've introduced something that we've called, or that we refer to as vSAN IO Insight. It was known as IO Insight before. And IO Insight basically provides you the ability to trace virtual machines from an IO perspective. So it gives you an in-depth overview of what the virtual machine is doing from an IO standpoint. Now, I think it's probably easy just to show you what that looks like, because a demo, I think in this case, makes it immediately clear what the value is of this particular feature. When you right-click the cluster or right-click a virtual machine, you have the option to create a new IO Insight instance. And when you create a new IO Insight instance, you can select the virtual machines that you would like to monitor. In this particular case, I'm going to monitor, because I only have one virtual machine, my vCenter server, and I'm going to be monitoring that for 10 minutes. You can do that up to 24 hours, but of course, I want to make sure that I'm able to show you the demo within, or the data within a reasonable amount of time. After I started the monitoring, this IO instance is going to be started on the host where the virtual machine is running, and then after, when it's running, you can go to monitor, you go to the vSAN section, to the performance section of vSAN itself, and then there's a IO Insight option within that performance section. When you click that, you will see the instances that are currently running or did run in the past, and you can look at the data of that as soon as it has been completed. It shows you how long it's running. So in this case, it is running for 10 minutes. Of course, I sped up this part of the video. And then after it has completed, what we will do is we'll start looking at the data that is gathered for this particular instance. We can click on the three dots. We can click on view metrics, or we can rename it, rerun it, or delete it. But in this case, I just want to show you what it looks like. Now, if you look at the data, you can instantly see that we gather a lot of data, which is normally not available within the performance overview. Of course, IOPS and throughput is available in the regular performance overview, but whether the IOPS whether the IO is sequential or random, for instance, is fairly difficult to figure out. But that is available by looking at this trace set. Not only that, but also showing you whether the data is 4K aligned, what the read-write ratio is, what the IO size distribution is, and of course, what the latency distribution is. We're not just doing that for one virtual disk, we're of course doing that for all of the different virtual disks that are attached to this particular virtual machine. So I think this information will hopefully allow a lot of customers to do more in-depth troubleshooting around what a workload is doing in their environment, and especially in cases where you have customers complaining about latency or whatever it ends up being. This may provide additional insights around what is happening in your environment. Now, we're trying to take that to a new level, and this is something that we don't have available yet today, but it's something that we are actively working on, and that is something that we refer to internally as the IO trip analyzer. Now, with the IO trip analyzer, you will still have that capability that we've just shown, where you can basically through a one-click analytics platform start looking into data that is available. But not only will we show you that in terms of these graphs with all of the different metrics, we're also going to show you that in form of a diagram, which shows you the flow of the virtual disk itself, all the way down to potentially even the capacity tier and all of the different layers in between. So if there's, for instance, latency from a network perspective, we can instantly show you that we have latency on that particular layer, which then hopefully will allow you to have a conversation with the networking team or anyone else in the organization that may help resolving the problems that you are facing. And hopefully this will make troubleshooting, especially performance troubleshooting, a bit easier in one of the upcoming releases of vSAN. Now, I can't mention when this is. This could easily take another 12 to 18 months, but I can guarantee you that this is something that we're actively exploring today. With that, we've reached the end of the third part of the vSAN, or I probably should say cloud native roadshow, at least my part of the vSAN, or my part of the section, which was on the topic of vSAN. I hope it is something that you guys enjoyed. I noticed Cormac had already answered a bunch of questions. I'm not sure if there's anything that he would like me to expand on. If not, I would like to thank everyone for your time. Of course, feel free to connect to all of us on Twitter. I've mentioned my IDs here, but of course you can connect with Frank as well, Frank Denneman on Twitter, and Cormac J. Hogan on Twitter, and of course feel free to connect to us on LinkedIn or on YouTube. Cormac, was there anything you would like to me to expand on, or did you answer all of the questions through the chat?
Yeah, there was one in particular, Dunk. I think you covered it with the stretch cluster, but would you be able to confirm that 2-node vSAN clusters can also now support HCI mesh?
Well, it depends on how you look at it. So a stretch cluster configuration or a 2-node configuration cannot be used to connect to, but you can connect from a 2-node configuration to another cluster. So that is something that we support, but we don't support a 2-node configuration being used as a capacity layer but that's probably the way I should describe it, as the server layer for another cluster. So that is something that we don't support yet. It is something, of course, we've had that question before, and it's something that we are exploring. We may or may not, provide support for that. If there's a particular use case that the person who asked the question is looking for or has in mind, just please let us know. But we support all different types of configurations, right? Last week when we did the session for France, we had a customer asking if a single host could connect using HCI mesh to a vSAN cluster. And Cormac and I looked into it and actually created the demo for that as well. And that is possible when you add that single host to a cluster. We need to have a cluster object in this particular case to enable vSAN. But of course, you can simply disable HA and DRS and just connect back to that vSAN cluster. So that is something that we do support, but you can't connect to a 2-node configuration or stretch cluster just yet. But this may or may not be something that we'll support in the future.
Okay. Yeah, that was what I wasn't clear about. So my answer was a bit mixed, I think. So hopefully, Alan, if that answers your question. If not, just, you can ask another one. We still have a few minutes, I think. That was about it, really. There was some interesting, there were some interesting questions. I think we should take, we'll get a copy of the Q&A anyway, see if there's some of these we can follow up on.
Yeah, I was just looking at the some of the questions, and I'm not sure who DD is, but having the ability to tear data from vSAN to S3 for file share use cases, I think that is a very interesting question. I think it's a very valid question. I can imagine that that is definitely something that the product management team is already exploring. As you can imagine, we released vSAN file services with vSAN 7.0. We've expanded it with 7.0 update 1 and update 2, and we will be looking to introduce new capabilities in the future. Things like these, tiering to S3. I can imagine that that is something that we could potentially release in the future. It is definitely something that I think would be interesting. So please share, your particular use case. I see that Cormac shared his email address, so feel free to spam Cormac with all of your requests or anything else you may have. We'll make sure that we'll feed it back to the product management team and the engineering team.
Yeah, so I think the rest of them we're caught up on. Okay, yeah.
Awesome. Well, let's hand it back then to the VMUG leadership team so they can close the session. Thanks, everyone.
Yeah, thank you.
Thanks a lot, Frank, Duncan, and Cormac. That was a great roadshow with lots of informative sessions. Quite nice interaction with the audience, quite a few questions. Thanks also for your availability in taking those questions and answering them. I don't know if Lino, Antonio, or Francesco have some closing remarks.
Oh, we will thank. I will thank our guests for the participation and our speaker for the great session.
Yes, thank you very much for your participation. It was a really interesting stuff here. It's always interesting stuff you are going to present to our guests. And yeah, I don't have any question or any remarks, but probably people will have some question. Yeah, rewinding all this session and then yeah, as I can see, you have shared your contact, and for guests here, feel free to ask them. They are really nice guys, then can answer all your question. And yeah, not for not other words from my side. Thank you very much. Thank you again.
So of course the sessions were quite packed with information, so very concise, very dense. Yes. And I believe many of the attendees can maybe go back and see them multiple times, and maybe more questions will rise from from that replay. So thank you again very much, Frank, Cormac, and Duncan, for being here with us today. It was great, and thank you to all attendees and participants of this roadshow. We look forward to interact again with you in the next month, and hopefully have this trio or part of it in some next session in the future.
Sure, would be great.
Thanks, everyone.
Thanks.
Have a great rest of the day. Take care.
Take care.
Bye-bye.
Okay.
Bye.